Force. We can observe many changes around us, like changes in seasons, change during sunrise and sunset, changes in the tides of sea, etc. Do you know about the cause of their changes? In order to know the answer for that question, let us observe these examples carefully. To move a book placed upon a bench, you must and shouldly apply some effort. Similarly, a strong wind causes the branches of a tree to swing, and a flowing river causes the motion of the boat without anyone rowing it. By observing these examples, we can see that some external effort or an invisible effort was responsible for the changes occurring in nature. That external effort was simply named as a force. Up to now, we are studying about the concept of force. From these experiences, can we define force? Yes. Force is nothing but an external effort which is needed to move the body. That means, if we want to change the position of a body, we must and shouldly applying some effort that is called as a force. From this common experience, in how many of the cases in your daily life we are applying some effort? The words force, effort, strength, power having the same meaning at that time. Have you ever wondered what forces are? To know the answer for this question, let us observe these examples. If we want to move a football which is placed on a ground, you surely kick on it. That means we are directly applying some effort on ball. In the same way, we want to move a stone resting on your hand. We apply some effort in upward direction. In the above examples, we are directly applying the force, that is, in contact with the bodies. Is it necessary? No, not at all. For example, just we release a stone placed in your hand, we are not applying any force on a body. But the stone is moving in downward direction. And similarly, some iron fillings placed near the magnet, what we observe, the iron fillings were attracted by the magnet. In this case, magnet apply some effort on iron fillings. Here, the force applied by the magnet act at certain distance. That means this force is acting when both iron fillings and magnets are not in contact also. By observing the above examples, we think about the types of force. Observe these examples carefully. In order to move a cycle, if we apply some force on a body, a force can start or stop a moving body. A ball laying on a ground moves when it is kicked. The pull exerted by the horse makes a cart move. The pull exerted by a steam engine moves the train. The force applied by earth, that is gravitation pull, makes an apple fall. Likewise, a moving body can be stopped by applying a force in the direction opposite to its motion. The push exerted by a broom moves the rubbish. List more activities where we exert force which appears as a push. List out more activities where we exert force as a pull. List out the actions which involves both push and pull. Now, we have to know about types of force. Any of the object slips off your hand in this situation, what we observe? It always pulls down. That is, some effort pulls down such a bodies. If we move a ball on a level ground, what we observe? Does the ball move forever? No, the ball does not move at all. After moving certain distance, ball comes to rest. That means something, that is, some force opposes the motion of a ball on a ground. Here, what makes the ball stop? Force makes the ball to stop it. And some forces are acting on a body directly in contact, and some of the forces acts on a body certain distance. Forces are divided into two categories: contact force, non-contact force. How to define a contact force? The force which acts on a body when they directly in contact with the bodies, or force which results in when there is a direct physical contact between two interacting objects, known as contact force. To find the limiting force that can be made by a string. Non-contact force. The force which occurs without any physical contact between the objects is known as a force at a distance, or non-contact force or field force. Gravitational force. In our daily life, we all are observing any of the object slips off from our hand. It falls down on the floor. Why? Something is pulling the objects in down direction. Because of this reason, they fall down. If we keep the objects on any bench, they fell down? No. The reason is that the force is acting on a body is zero. But in further situation, net does not zero. Why does the stone thrown up into the sky come back and fall on the earth? Why do the rivers flow down to sea? How does the earth hold the atmosphere? Is there any force pulling the objects towards earth? Any object on the earth, or at least close to earth, will experience the force of gravity. It is a force which exerts between any two masses or two bodies in the universe. That force we called as a gravitational force. If you sit in your classroom, you and your teacher are considered as two bodies. Here also some force is exerting, and you and blackboard also some force is exerting, but you did not feel that force because it is very less when compared to the force applied by earth on every object. Because earth is a huge massive body than any body on the earth. Weight. The force exerted by the earth on a body is called the weight of the body. It is acting vertically downward direction, and that force of pulling is towards the center of the earth. It is not a contact force. Even if an object is not in contact with the earth pulls it. That force applied by the earth can be calculated by W is equal to mg, where m is mass, g is acceleration due to gravity. Magnetic force. You might have observed that a magnet pulls small iron nails or pins when they are brought nearer to it. It means the magnet attracts these objects. This force exerted by magnet is called magnetic force. Many toys work with magnets fixed in them due to the exertion of magnetic force. And we know that like poles of magnet attract with each other and unlike poles repel each other. This is also due to the magnetic force. This force is also acts on our bodies when not directly contact with magnets. Such a force is also called as a field or non-contact force. Electrostatic force. Take a plastic comb. Comb your dry hair for a minute. Now, bring a comb near to the small pieces of paper. What will happen? You will observe that comb attracts the pieces of the paper. This is due to the electrostatic force. Here, we comb our hair with a comb. It occurs an electrostatic charge in its surface. The comb is now said to be charged body when it is brought nearer to the pieces of paper. The paper pieces acquires opposite charge and fly towards the comb. Explaining a force acting at a distance, concept of field. We can explain the force at a distance by the concept of field. Let us do. Take a magnet that is placed in a soil. We observe that some pieces are attracting to the magnet. Collect them. What are they? They are iron fillings. Take a white paper and a table. Place a white paper on the table. Place a magnet on the paper. Now, iron fillings are placed near the magnet. What do you observe? Do you observe any pattern of iron fillings? Yes, iron fillings set themselves in a pattern because they are affected by magnetic force of a field created by a magnet. Net force. Many forces act simultaneously on a body. For example, a book is placed on the table. There are two forces acting on it: gravitational force and normal force. Here, object is moving. Book is not moving. Why? Because two forces are acting in opposite directions and are having same magnitude. Then there is no motion of a body either in horizontal or in vertical. That is nothing but even though some forces acting on a body is at rest, or there is no change in its state. Technically, we say that net force on this object is zero. Several persons applied a force on a heavy car. These forces together produce the motion in the car. The sum of an efforts applied by several people equals the net force. Thus, we conclude that the forces which are acting on a body in same direction result the heavy amount of force. This is called result force or net force. That is, forces applied in a same direction on an object gets added. That is, F equals to F1 plus F2. On other hand, if two persons push a cart from opposite directions, result F acting on the object is F equals to F1 minus F2. Thus, two persons moves a cart in opposite direction by applying same force. Does the cart move? No, it will not move. Because the forces are balanced with each other, the resultant of all forces becomes zero. As the forces begin equal and opposite, so they cancel each other. Such forces which result in zero resultant force are called balanced forces. Otherwise, if the resultant of several forces acting on a body is not equal to zero, the forces are called unbalanced forces. Note: when unbalanced forces are acting on a body, the body will accelerate in the direction of net force by satisfying the formulae net force equals to ma. Effects of a net force acting on a table. Try to push a heavy wooden table. Is it easy to push or is it hard to push? If we move a table, suppose it does not move, then we ask your friend to help you in pushing a table. Now, what we observe? Do you find it is easy to move the table now? Yes. Why? What is the reason? The reason is that first you only apply some force on table to move it. Later, your friend also join. That means some additional force also is applied on the table along with you. So, total applied force by both of you made it easy to move. Now, do the same activity but simply change the direction of the force applied by your friend. Means, you and your friend pushes the table from opposite direction by applying the same force of magnitude. What we observe, is it moves? No, because both forces cancelled with each other, net force equals to zero, so it does not move. For example, if you apply more or large force than that of your friend, at this situation, does the table move? If it is moving, what is the direction of the moving table? What we observe? The table moves in a direction in which applied force is more. Note: to add forces, sign convention must be used. We all know about rubber bands. If we stretch the band with your fingers, that means we are applying some force on band. Similarly, band is also applying the same force on fingers by Newton's third law of motion. Instead of taking a one band, if we increase the one or more similar bands around your fingers, stretch all together to the same length. What we feel? Do you feel the combination of bands exerts a large force than that of one? Yes. The number of bands increases, the force is also increased. Let us say force exerted by one rubber band F unit, and the force exerted by another one is also F unit. Then, what about the total force? Net force is equal to F plus F, which is equal to 2F units. Think, what is the net force acting on your fingers when more rubber bands are used? How to calculate net force from free bodies diagram? The diagram showing all the forces acting on a body is called as free body diagram. For example, take a car moving on a road. Step 1. Represent the forces acting on it. Force applied by engine towards right. Frictional force applied by a rod towards left in horizontal direction. In vertical direction, contact forces on two wheels and a force of gravity downward. Normal forces are named as N1, N2 vertically up. Gravitational force acts vertically down. If body only moving in horizontal direction, that is, along x-axis, net force equals to F minus F. Along vertical y-axis, net force equals to N1 plus N2 minus W. Effect of force. Force can change the state or direction of motion of a body. To move a cycle in forward direction, we apply a pulling force or a pushing force. In the same way, your friend is going on bicycle. If we want to stop the body which is moving, what we do? We apply a force in the direction opposite to your applied force. Then what happens? Your applied force is sufficient. The cycle comes to rest position. By the above activity, we can say that force changes the state of body. That is, it moves the body that is initially at rest or stops the motion of a moving body. In a tennis court, batsmen apply a force on a ball by a bat in different directions. From this, we say that direction of force applied increases or changes, then direction of motion of a body also changes. Effects of net force on direction of moving object. Have you ever seen carom board? Yes, If you strike the coins with striker, does the coins move in same direction? No. What is the reason? The force applied by the striker on coins is different in different directions. Striker only changes the direction. No, not only it changes the direction but also changes the state of a body. Does the force only change the state of motion? Are there any other effect of forces? Other effect of forces. Force can change shape of an object if we squeeze some objects like tomatoes, eggs, a balloon filled with air. What we observe? We observe any change in the shape of a body? Yes, there is a change in shape and size of a body. Do an activity in your home. Observe the shape of the objects carefully before and after applying the force. Pressure. Why do the porters place turbans on their head when they have to carry heavy loads? Why the vegetables can be cutted with the sharp edge of a knife? Why do the school bags and shopping bags have both straps as handles? Why it is easy to drive a sharp end of a nail than a wider edge or end? In all the above examples, we say that if we apply the same force in all the situations, but the work done by the force is different, drive a nail into the wall. Is it easy to drive the wider end of nail onto the wall than sharper end? No. Why? What is the reason? You apply same force on both ends. We observe that the sharper end is easily driven into the wall than wider. And because the sharper end occupies less area than the wider end, same amount of force on both ends, the work done is different. Here, some force is acting in unit area of cross section, that is called pressure. By observing above example, we can say that occupying area of contact, more pressure active is less. If the surface area is small, the pressure will be greater. If you use a large area, you observe that for the same force, area increase, pressure decrease, area decrease, then pressure increase.